Today we will talk about SQL versus NoSQL databases. In most of the projects nowadays, we have seen fierce debates happening between whether to go for SQL databases or to go for NoSQL databases. We have also seen that even in current projects, people still have this debate going on that whether they have gone, whatever route they have taken is turning out to be the right route or they should have taken the other way around. So what we will do is that we will look into these two databases from certain levers, basically like what criteria you can evaluate between both of them and then make a choice decision. We just have to be careful that frameworks should be chosen to serve the project and not the other way around. Whatever is in the fashion in the market might just help you in getting the team members the next big job, but may not be good for the project. Okay, so I think the most important thing is always to understand your context, see that what you are looking for, and then once you have a clear understanding of the need of your project, then start making choices about which one you should adopt, and you should be comfortable with the reasoning behind that choice. Okay, so what we'll do, let's take a simple example to start with and see that how it will flow in the SQL and the NoSQL world. So what I'm going to do is that we'll just make a small use case. Let's say user, it has a product and there is an order. Okay, and we will say that in the order, for simplicity's sake, one user is only buying one product. Okay, so user in the SQL world would be ID, name, product, would be ID, name, and maybe list price. Order would be basically, again, good idea to have an ID. We can have an order date, we can have a foreign key to user ID, a foreign key to product ID. We might just want to keep the list price also here because the list price might keep changing. So we know that when the order was created, what was the list price, and then we can have the selling price. This is how very simple SQL relational data model would look like. Okay, now let's use the same use case and see that now in the NoSQL world how it will flow. So in the initial what I'm going to do, I'm just going to map this into the NoSQL data model world. So actually in NoSQL what we call is there is no data model as such. There is just data, and usually it's in the form of JSON. So what would happen is that in the SQL world it would look something like user would be, we can make it like ID is equal to, let's say 100, name is equal to ABC. Okay, and how the product looks like, let's say ID 500, name P1, and list price, let's say 5.43. And for the order, ID is equal to 799. I'm just throwing some numbers. Order date, let's say 19/02/2018. Then we have user ID, which is 100, product ID, which is 500, list price 5.43, and let's say selling price is 5.22. Okay. A very simple straightforward mapping from the SQL to the NoSQL world. One thing you would have noticed that here I have put it in a meta definition format. Same thing like the definition with the difference between class and objects. But here you would see that I've actually put actual numbers. So that brings us to the one of the most important point, which is like SQLs have schemas and NoSQLs are schema-less. So I might have a user table here, I might have a product table here, and might have an order table here, but generally I can't enforce the kind of data that is going there. They are all schema-less. In user, in one of the row, I might have this one. In another row, I can put any other data. So for example, tomorrow I introduce a name and then introduce a last name also. Okay. In the SQL world, I have to go and modify all the records, because when I introduce this column, it will impact the existing data also. Here I don't have to worry about the older data. I can just start adding last name into the new set of items. Okay. So that also brings us to the most important point, is that there is a schema, and which is a very well defined schema with certain rules in place. So for example, you will have a very strong rule in terms of that order should contain so many attributes, or there should be default, but they can be more or less than this. And also the data types, the strongly typed ones. Okay, so that brings us to the first point of SQL, NoSQL versus NoSQL. Okay, now let's little bit focus on the NoSQL. What we are doing is right. So let's take a step back. There is another thing to be understood about SQL and NoSQL world. SQL worlds are what we call as schema-driven world, and NoSQL worlds what we call as query-driven worlds. So in the NoSQL designs, it's very important for you to understand basically that what are the use cases that you are going to solve using the NoSQL world. Okay, and then accordingly you design your schemas, basically how the data is going to be laid. Okay, so for example, if I want to find the order for a given user, I can do a quick join here. Here there is no concept of relations, so you can't do joins. So that also brings us to the another important aspect, which is the relations. In the SQL world, you can build relations. You can say that this is like one-to-many, but in NoSQL world, there is no concept of relations. So essentially, if you want to fetch the name of user, product and order all in one go, here you can do a query using joins, but here you'll have to fetch the order, take this ID, go and fetch the user item, take this ID, go and fetch the product item, and then build the whole aggregation together. So that's why in the NoSQL world, we say that you need to understand your queries very well and accordingly design the schema. So what would happen in the NoSQL world is, usually the first thing is, if you have a requirement that you have to fetch your orders, then what you are going to do is basically you are going to have this information of user and product built inside it. So what it would basically mean is that, let me remove it from here, and so what would happen is that you will just start putting ID 100, name ABC, then your product ID 500, name P1, list price 5.43, and then we have a selling price 5.22. Okay, so this is how you would start dealing with the data in the NoSQL world. So what you have done, you have baked all the data in this item itself. Now when you fetch it, you don't have to go and look for any relationships. So data duplicacy is very common in NoSQL world, and the integrity has to be maintained, ensured by you at the application layer most of the times. Yeah. And also again, I have put IDs here, but these IDs are not similar to the IDs you see in the relational world. Okay. It doesn't provide any such notion of ID. You can just have a unique handle. NoSQL you can also think of more in terms of like a map, a key value pair. So for each item you can decide one thing as a key and rest all become basically the value of the map. So ID can be a unique handle to reach to you, or you can as well use some name or something like that. Beyond that, it's not going to help you or aid you in terms of relational integrity or anything. That's not going to happen. Okay, so what it means is that if by mistake I put XXX or let's say ZZZ, it's not going to matter. Okay, the NoSQL database would happily take that data. So the data integrity is basically you have to take care of different layers in different ways. There are some transactional systems now supported. But again, I would say that NoSQL are not what are designed for the asset integrity, which brings us to our third point, which is the transactions. So NoSQL databases provide very strong transactional integrity in terms of asset properties. NoSQL database generally has not have those notions, and you have to also understand that it's from the perspective that that's why NoSQL provides a lot of scalability. We'll come to that in a bit. Okay. So, and then queries we touched briefly. In terms of queries, we know that you can do complex joins and things like that in SQL databases, which is not possible in NoSQL databases. Okay, so hopefully you would have understood SQL and NoSQL in terms of like schema, relations, transactions, and queries. Let's briefly look into the scalability part of the things, that how they match up against each other. Okay, so usually when we talk about scalability, we talk about two kinds of scalabilities. One is horizontal and another one is vertical. In relational world, you can scale vertically to an extent. The things that will start slowing you down would be the relational integrities, and then queries also become slower. You can make indexes for that, but the moment you make indexes, your updates and inserts take a hit. So that's why. So you can scale them up, but to an extent. Okay. On the NoSQL world, you see that there is no relational integrity. In fact, each item is independent of the other item. Even in the same table, that one item doesn't care about the another item. So you can just keep on scaling vertically. Okay. There is as such no technical limitations from the conceptual side to go and scale up vertically. On the horizontal side, in the SQL world, again, if you look back and see that because of relational integrity and all, and if you start putting more machines and still the relational integrity has to be maintained, you know that there is some work now needs to be done. So that's what, so there is one popular concept called sharding in the SQL world. You can put multiple machines, but then usually there is a layer on top of that which takes care in terms of making sure that the relational integrity is going across the machines. It's not trivial to build that kind of system. SQL world, you can keep adding machine, the same argument as for the vertical one. As long your data has no relationship, no dependence on each other data items, so you can just keep adding machines. Okay, so now come to the $1 million question: which one to choose? Okay, so I think you need to look into the whole set and not just get carried away with one. You'll have to understand how strongly typed you want your schema to be, because that basically drives your data integrity also. One of the biggest problem that happens with databases is that if there is some bad data gets into that one, it's very difficult to clean up. You also have to understand your query models and what kind of use cases you are basically dealing with that, and at the end what kind of scalability you are looking for. Okay, so my take on these things is that I think it's true that it has to be driven by based on your project, but I think most of the use cases, most of the projects that we run, kind of scalability we deal with. I'm not talking about the big large applications of the world, but generally the day-to-day regular enterprise applications. Let me take a step back and say this, that I think it's probably important to understand that why you don't want to use SQL. I would rather start with that one. So if I put it more strongly, I would say that I would first consider SQL, and then I would try to find a good use case in terms of that, or a good reasoning that why I am not using SQL. Okay, and that's where I'll start looking into NoSQL. The other approach is that, which is also very common, and I think which is actually my preferred approach also. You can actually go with a hybrid approach. Make sure that your business data, or the data that needs the integrity in terms of data integrity, transactional integrity, you are keeping it in the SQL, and then the data that doesn't need that kind of integrity, like the time series data or the clean stream data, you can just put it in NoSQL. As a matter of fact, nowadays, like even a database like Postgres, they provide this JSON kind of NoSQL data holders also. So that is again a possibility to use. So in a nutshell, I would say that be very careful about your choices. These two choices are not trivial choices. It will make a lot of difference in terms of cost and effort that you are going to incur later on in the project. Okay, so be careful. Just don't think about scalability, just don't think about integrity, think the whole set, think about the data model integrity, think about the relationship integrity, think about the transactional integrity, think about the kind of queries that you're going to run the system, and then think also about the scalability, and then take a decision. Hopefully it would turn out to be a right decision when you will proceed further in your project life cycle. Okay, thank you very much. Thanks for your time.